Heavenly Father, just thank you again for the day. Thank you for the blessings you've given us. Thank you for the students here. Just pray you may help them in their classes. Just guide them in everything we do in Jesus' name. Amen. All right, questions on your homework?
All of them.
All of them.
Yeah, no, seriously, Mr. McLaughlin, I really didn't get it.
Once I actually had them.
I got number 1 right, and I got number 33 right.
Once I had the double angular whatever written down correctly, it was pretty easy.
All right, it says use the appropriate sum or difference identity to prove the double angle identity. So you got cosine 2 theta, which is number 1, correct?
Yeah. Wait,
So what?
It's 2u.
Sum
it's 2u.
2u, okay.
And then it's
What sum
cosine.
identity will you use?
Why do you have to use one if they equal each other?
Because they do.
Because they're asking you to prove it.
Oh, I didn't realize they wanted us to prove
Cosine
it.
2u equals.
That's why they say use.
I got number 1 wrong, actually.
Use the appropriate. The instructions say use the appropriate sum or difference identity to prove the double angle identity.
It's just one step.
No.
Yes, cosine 2u.
No, it's not necessarily one step, no.
Well, how's it not? It is.
You said
Stop with the sorcery,
you
Mr.
have to prove
McLaughlin.
it, apparently.
Cosine. I veto your veto.
You got my heart.
What is that? What's that?
He's using the cosine property. So cosine, cosine, sine, sine.
Make it way more complicated than it needs to.
No, it's not. Listen, what did they ask you to do? Use the appropriate sum or difference identity.
Yeah, but doesn't cosine 2u equal cosine squared u?
No, but
Yeah.
they're asking you to prove it.
Oh.
To prove it,
So cosine
all right?
u squared.
Just because you tell me you're the best basketball player in the world doesn't mean I have to believe it, just because you say it.
That's because
I need you to prove it, all right? So just because they say that this is equal to this doesn't mean you have to believe it, you have to prove it.
I'm your favorite
So,
student in the
That's
world.
what, and you would have to prove that.
I can prove it too.
Yeah, yeah, right. So, you gotta go from cosine 2u to equal cosine u plus u,
Mhm.
then use your identity. Oh, that's cosine u, change the sign, sine u. Now you can say it's cosine squared u minus sine squared u.
Got it.
And now you have proved it, and that's what they wanted you to do.
Got it.
I used the half, the double identity.
That's crazy, man.
I changed cosine square u to 1 plus cosine 2x over 2,
For number 1,
yeah.
well, that's not using a sum or difference identity.
But I can have just,
Amy, they wanted us to use a specific identity, and the identity you used was wrong.
Sum or difference identity.
There we go. So how do you do number 5?
U turn sine.
Find all the solutions to the equation. Sine 2x equals 2 sine x.
Mm-hmm.
Alright, so we're gonna use the double angle identity. Cosine, sine 2x equals
2 sine x cosine x minus 2 equals 0.
anytime we're asked to solve, we have to set it equal to 0, so we're gonna bring everything to one side.
Wait, why do you know that it's 2 sine x cosine x?
Because we memorize it.
Double angular thingy.
Oh, so I wasn't wrong for using that.
Now we're gonna factor out the greatest common factor, which is 2 sine x. Set each factor to 0, 2 sine x equals 0, cosine x equals 1. So I'm going to look at sine x equals 0. Where does sine equals 0?
Pi.
0.
I mean, yeah,
0 and
pi.
pi. Where does cosine x equal 1?
Pi.
0.
0.
So therefore my answer is 0 and pi.
So is that what you do for number 9 as well?
Yes, sir.
Well, what property do you use for that?
Same property.
What kind of angle do you have?
Sine 2x minus tangent x.
What does 2x mean?
I don't know, double
Double.
angular.
Double angle, correct. So what trig function, what trig identity would you use?
I don't know.
Well, double angle.
This one's water.
So here, number 9, you got sine 2x minus tangent x.
I have a question
So
number
sine 2x is gonna be 2 sine x cosine x. Tangent is gonna be minus
Sine x.
sine x over cosine x. If you get a common denominator, which is cosine x, that's gonna be 2 sine x cosine squared x minus sine x over cosine x. So now we can cross multiply to get 2 sine x cosine squared x minus sine x equals 0.
Wait, why did you get, oh, you cross multiplied.
Now I can factor out the greatest common factor, which is sine x. And I'm left with 2 cosine x squared x minus 1 equals 0. So now set each one equal to 0, sine x equals 0, and this is cosine x equals plus or minus square root of 2 over 2. Just take the 1 over the other side, divide by 2, that's 1/2. Take the square root of 1/2, the square root of 1/2 is square root of 2 over 2. We take the square root, it's plus or minus. So what do I take the sine of that would give me 0?
Pi.
0 and pi. What do I take the cosine of to give me square root of 2 over 2? Pi over 4. Plus and minus, that means I need one in every quadrant, so pi over 4 in the second quadrant is 3
Wait,
pi over 4.
how'd you get square root of 2 over 2 for cosine x?
Take the 1 to the other side,
Yeah?
divide by 2,
Mm-hmm.
take the square root of 1/2.
Take the square root.
You gotta rationalize?
Yes.
Cause you had rational.
Pi over 4 in the third quadrant,
Is 5 yeah.
and pi over 4 in the fourth quadrant.
7 pi over 4.
So there's my angles. 0, pi, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4.
For number 5, can you cancel 2 sine x and 2 sine x and just have cosine equal 1?
Now you got a factor.
But if
Don't forget about your algebra rules. All it is doing algebra. We're factoring. We're solving by factoring. We factor out the greatest common factor, set each factor equal to 0, and solve. All it is algebra with trig functions. Can't do something that you're not allowed to do in algebra and trig. Can't just cancel those out. You change the equation.
Well, let's start something new. Cancel, make the cancel rule.
Any other questions?
21.
Which one?
21.
Alright, so you're gonna start on
Or
the left. We're gonna change cosine 4x to
cosine 2x times 2.
Alright, so we got cosine 2 times 2x. So we're going to use a double angle identity. Alright, all you need to determine is which one do I want to use. There's 3 to choose from.
1 minus 2 sine.
Cosine squared x minus sine squared x.
Okay?
cosine squared x. How do you get it?
Do you use like the power ones,
What?
the power reducing ones, or no?
Now, because the power reducing one would give me a cosine 2 theta, right? And our job was to get rid of that. So now,
Couldn't you make it 1 minus 2 sine squared over x? And then,
so now use that one.
and since there's the 2, it's to the power of 2.
What do you think?
You square it.
You square it? Well, if we square it, we get sine to the 4th.
No, it's 2, then you make it 2 sine x squared, and that'll bring it to 4 sine x times, or 1 minus 2 times sine, 2 sine x.
Or do you just factor it out?
How are you gonna factor?
I don't know. I'm just throwing out ideas.
Or is it like 2 sine square 2x?
What's that?
2 sine square 2x? Because is cosine 2 times 2x?
No.
Shouldn't it be 1 minus 2 sine squared 2x, not just x?
Okay, you are correct.
And then,
Wait, how would it?
because
Oh,
you have to
because it's
plug it
in,
in,
yeah.
and then from there, you have to subtract 1.
Would it
No.
sine squared or
Excuse me?
Sine 2x,
sine?
2 sine 2x.
And why would you do that?
Is that what sine squared x, or is that what sine squared 2x means?
Yes, but if you, because you're multiplying them, okay, I got it. I see what you're saying now.
What's sine 2x equal?
Sine 2x equals,
Two
it
sine
equals
x
2 sine cosine x.
Okay. Now what?
And then,
You square it, so it'd be 4 sine.
and then you multiply it out.
Yeah, then you multiply the 2, it's 4.
Correct?
If you're multiplying the 1 into the 4 sine squared x, squared, cosine squared x, why don't you
We're not multiplying 1 into it.
you're not?
No, just what's outside the parentheses.
Got it.
Any other questions?
Number 13.
Which one?
13.
We already passed that, Amy. Alright, number 13, it says write the expression as 1 involving only sine theta and cosine theta.
Plus cosine 3 theta.
Alright, sine 2 theta, that one's easy. That's gonna be what?
That's gonna be, 2 sine x, cosine x. Well, theta, sorry.
Right? And then cosine 3 theta, then we want to change that to cosine of 2 theta plus theta. we're gonna use a sum identity, which that means that is going to be cosine 2 theta, cosine 2 theta, cosine theta minus sine 2 theta, sine theta.
And why are we using the cosine identity?
That's the only thing we can use, there's nothing for 3 theta, correct?
Yes, but, oh, cause you had a factor in it.
Alright, cause we don't want any 2 thetas or 3 thetas. Now we can get rid of this 2 theta. What do we want to change it to?
Which theta?
It's cosine 2 theta.
I don't know.
Cosine.
Cosine squared theta minus sine squared theta. And we want to change this sine 2 theta into cosine cosine. So you distribute, and so we have a sine squared cosine and sine squared cosine. So we can simplify that to cosine cubed theta plus 2 sine theta cosine theta minus 3 sine squared theta cosine theta. Now there's a multiple of answers that you could get depending on what you use for cosine 2 theta. You could get some other forms or different ways that answer could be written, but this is one way.
If they wanted, what was the point of doing all that?
To get rid of the 2 theta and the 3 thetas.
But you still ended up with 2 sine theta and cosine theta and 3 sine squared theta and cosine.
But there's no double or triple identities. Or triple angles. It's all single angles. Even though we may be squaring them, it's still only single angles. No doubles or triples.
But isn't 2 sine theta cosine theta a double angle?
No. Because the angle itself is single. Doesn't matter what the trig function, the angle itself, the theta. So this here is a double angle, because theta is the angle, so double angle. But here it's just an angle, just a single angle. Yes, sir.
So I have a question. On this last part, the thing where they can combine, do you combine like terms, or do you just?
We're multiplying.
Okay.
Oh, this last part we combined like terms.
Okay, so,
Yeah. They're both sine squared theta, cosine theta, so we can combine those.
okay.
Just be like if it was an x squared y, you
Yeah.
can combine x squared y.
Okay.
X squared y. Any other questions?
How do you do 29?
I can't do that one, I don't know how.
Me either.
We really don't know how?
Yeah, I do.
I mean, if you don't know how, that's fine, I'm totally fine with how.
25, 35, 33, 35.
Do we have to do 35?
No. Things were finally going well in this class, and then it all just blew up.
Wait, which one?
What you asked for, right, 29?
Yeah, it is, sorry. Okay.
Well, did you get shot in the leg? Because everyone thinks you got shot in the leg. Did you get shot in the leg?
No,
What happened to your leg?
I don't get why everybody's got shot.
She was squirrel hunting, okay?
Like rubber bullets or something, just
No,
right in the leg, like in training.
the shell bounced off of the squirrel's head and came back at her.
You say some of the weirdest things here. Right? Look, he doesn't know how to do 29.
Now, they said to use a graphing calculator, but I think you can do it without a graphing calculator.
I try to do it.
Are you in radians or
Oh, yeah, no,
degrees?
29,
I got this weird graph looking thing. And then I
It
tried
looks like a heartbeat.
Well, I did do
It does. Anyway,
Imagine having a heartbeat.
it didn't work. What?
Just wanna double check to make sure.
Well.
You got my
I mean, isn't that basically the same thing as
It's like the fifth
the
time you
number
saying that.
13?
Okay, and
Okay.
So here they're just asking you to use a graphing calculator. This is, they all relate to, pi units. So what we wanna do, we want to graph sine 2x minus cosine 3x, make sure your calculator's in radians.
in radians or degrees?
Radians.
Yeah, or even 5.
Okay, so y equals sine 2x minus cosine 3x. Do we have to hit equal 0?
No.
So we just graph that. So graph.
You wanna be between 0 and pi, so you want your x window would be between 0 and pi, so that's somewhere between 0 and 4, or 3.5.
Wait. How do you
Window.
window is it? So you want your x to be what?
If we're looking for the interval between 0 and pi, so we're looking between 0 and 3.5 would be a pretty good one.
And what about y? Doesn't matter.
Doesn't matter,
Okay,
because you're looking for where it crosses the x-axis.
So, I think this might be wrong.
That's what you got?
That's what the window 3.5, 0, 3.5.
You see your y equals? No, y equals.
0, 0? You want to
No, I see what your y equals.
Oh,
Go to y equals.
yeah.
Alright, and you're in radians?
Yes.
Okay.
When it was different, it did something else. When I didn't have the same window.
Where'd your look like?
Can you put pi for your x max?
You could.
I did, I put pi.
What's yours look like?
This.
That's pretty.
Yeah. Oh, it's cause mine. Here,
Is this
if I
straight?
change my window to like -5, 5,
Yeah, that's what I have 5 about it.
then it's gonna be bigger.
Yeah.
Is yours curved?
Yeah. It's like a dragon.
Let me see.
Then you gotta hit a second calc,
0,
0,
enter,
enter, guess, quit,
Oh,
clear.
mine did the same thing.
Alright, second calc,
ah, I got nothing.
let's do value.
Or
9,
do you
clear.
intersect? Didn't you say x?
I'm find 0.
First
Oh, I
curve,
thought you said where it's
second
supposed to be.
curve.
Where it intersects the x-axis.
So you wanna use 0? Oh, I see.
That's my second curve.
Oh, that's right.
1.57 is the 1x.
For what?
That's what I
Intersect?
got.
0.
Well, how many zeros should we have?
2?
3?
Oh, 3, yeah, you're right.
Okay. Did you get the first one, the second one, and the third one, Shane?
Second one.
You get the second one. What do you get?
1.57.
Alright,
How do we know that there's 0?
get across the axis 3 times.
The first one is 0.134.
Oh, and so there's a specific window?
Point what?
0.314.
What's the third one?
I'm getting there.
Did you get 1.57? Yep, okay. I'm a little behind.
So is it just, are we just looking at the x-axis,
Mhm.
positive side?
zeros.
The third one is 2.82, or 2.83.
I got that too. Attaboy Shane.
Alright, so we want exact value, so we wanna find out, alright, divide those by pi. Divide this by pi, what do you get?
Why? Why do you make us do this?
Cause they want exact, so we want it in pi units.
0.4997.
This one here,
Oh wait, wrong one. I did the middle one.
what'd you get?
Divide by
0.4997.
I got 0.0999493043. Wait, do you want to, yeah, for 0.314 divided by pi, correct?
Right.
Yeah, 0.09995.
And the last one's 0.9008. 0.9008.
So just 0.9.
There you go.
So you just divided each of those by five?
Actually, Jessica, we divide by pi, then squared by 3, and then squared by 3.
Like to put it in pi,
That's what they asked. They asked for find exact solutions.
To ask for PI,
but if you divide by
personal investigation.
pi, how can it be
You got
pi?
shot when you were investigating something.
What is
So
You were running
What's,
away.
what's 0.01 times pi?
It really does look like a
Times
wolf
pi?
wound.
Yes, that's what we got.
If I were you,
0.01
it'd
times
make
pi.
a really cool story.
I know, that's what I'm saying. Then they
What do we
just
get?
started gushing blood because you got shot out in the parking lot. and
We
then
should
came
get
inside.
0.314.
Oh my god.
What?
Okay.
Look when you got shot out in the parking lot and then came inside. We took that.
Anybody else have any
The
questions?
leg was just gushing blood.
I wouldn't say that. That's probably not the smartest thing.
25.
Look at you,
Plus
Will.
cosine 3x.
Well, 25 was a long problem.
It's her own blood. It won't mess her
On
up.
her shoe. It's still
Yeah,
nasty.
she's a feminist.
You see, I don't know what that means, but I don't want to know what that means.
They're wrong ones.
Sure, it was horses.
No,
Not
that
dead
way,
bodies.
shoes.
Sorry.
What?
Obviously, there's been dead bodies. She was shot.
Are you trying to investigate right now?
No.
Yes.
I just want to know why she got shot in the leg. What do you do with your free time?
Cut your hands and then shoot yourself in the foot.
You cut your hands?
The one
Alright.
time.
Everybody with us?
You
Which number is this?
This is 25.
Okay.
Oh, yeah, yeah.
Oh my gosh, I actually did that right sometimes.
No, that was Peterson's little hatchet thing.
How did you cut your hand on Peterson's hatchet?
Cause it was dull and he wanted to cut. You know his little hatchet? Yeah,
Did you sue him for making you cut yourself?
I probably got him a lot of money for that.
Go ahead.
But we all know she's a drug lord shooting people and then she got shot in the leg.
Yeah, she was at battle yesterday and she dove and had a bomb and shot.
Yeah, dude.
Oh,
It was a drug deal that went south real quick.
Are you right?
Thought so.
Figured.
Wait, how did you go from that to that? What was the train of thought?
I want cosine 2x's and x's.
All my exes live in Texas, that's why I moved to Tennessee. George Strait. Huh?
Let me tell you, kid, you listen to some weird songs.
Dude, my playlist is like Cowboy Boot and Air Force One.
It's worse than that. You got the princess shoes on in there.
And then whenever Caleb
Alright, so we
plays
use our
music,
sum of
it's
different
some kind of
identities.
hippie vibe thing. Then whenever Caleb plays music, it's some kind of hippie vibe thing.
Cosine 2x cosine x plus cosine 2x cosine x. That's 2 cosine 2x cosine x. Sine 2x sine x minus sine 2x sine x cancels out. Equals 0.
Never mind.
Sure.
It doesn't make any sense to me at all.
Same.
But You multiplied it
from
out.
here to here,
Mm-hmm. Do you
well,
use,
x equals what? 2x minus x, right?
oh,
And 3x equals 2x plus x.
and then, okay,
Then I use my sum identities,
I see.
got rid of my sines, so left with cosine. So 2 cosine 2x equals 0, and cosine x equals 0.
So, pi,
So where's cosine x equals 0?
pi, no, pi over 2, no, yeah.
Alright, so here when you have a double angle identity, you have a technique that you want to use, right? So let's assume that a equals 2x. So we're going to have 2 cosine a equals 0, cosine a equals 0. So a, what angles do I take the cosine of that would give me 0?
Pi over 2 and 3 pi over 2.
But a is really 2x, so if I substitute 2x in for that, 2x equals pi over 2, and 2x equals 3 pi over 2. If I divide by 2, I get, I divide by 2, I get,
4, are you serious right now, Mr. Monroe?
but I need to go a little bit further
If you want one of all of the quantities.
because we want all of them. So the next one would be 5 pi over 2 and 7 pi over 2.
Mm-hmm.
If I divide that by 2, I get
4.
5 pi over 4. If I divide that by 2, I get 7 pi over 4. Is 7 pi over 4 in between 0 and 2 pi?
Yes.
Yes. So here are all my angles. All my angles are going to be pi over 2, 3 pi over 2, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Would be all my angles that would make it equal to 0.
So we get all 4.
And for 17, how do you do cosecant?
Did you use double or half angular identity for after you get when you get the 2 cosine 2x equals 0?
No, I just use a technique of substitution.
Mm-hmm.
I said a equals 2x.
Okay.
So a equals pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2.
Mm-hmm.
And I put the x back in and divide by the 2 to get x. We can check our answers. We don't put our answers in. Cosine of pi over 2 is what?
0.
And cosine of 3 pi over 2 is?
2,
Pi over
0.
0.
Correct? So 0 plus 0 is
0.
0. If I put pi over 4 in, cosine of pi over 4 is square root of 2 over 2, right? And cosine of 3 pi over 4 is? Cosine in the second quadrant is positive, negative. Cosine in the second quadrant, positive or negative? Negative. Negative square root of 2 over 2. Square root of 2 over 2 plus negative square root of 2 over 2 is? 0. That works. I can put this in. Cosine of 7 pi over 4. Put 7 pi over 4. Cosine. Square root of 2 over 2. Correct? And I put it in here. 21 pi over 4. Well, how many pi's? 2 pi's can I take out? 8 pi's over 4. And 21. 2. I'm left with
5 pi over 4.
5 pi over 4, which is in what quadrant?
The third.
Third quadrant, and reference angle pi over 4, so cosine of pi over 4 is?
Cosine of pi over 4 is square root 2
third quadrant is,
Negative.
so again, square root of 2 over 2 plus negative square root of 2 over 2 equals 0. So all of them work, and those are all my answers.
We need to go back to check.
You don't have to, but you may. I just did, just so you can see that they all do work. And they all are between 0 and 2 pi. So here is a train of thought that you need to remember. If I have a double angle, normally, how many values do I have for every angle I take the cosine of between 0 and 2 pi? How many answers do I usually have? 2. Okay, there's 2 places where cosine is positive and 2 places where cosine is negative. So I have 2 values. With a double angle, then I'm going to end up having not just 2 answers, but I'm going to have 4 answers. If it was triple value, then it would be 6, and so on. Because we're dividing it up into those sections. So here, when I knew I had 2x, I knew I'm just going to have just the 2 answers. I should have 4 answers. I just keep on going and getting those other values. How do I get my other values from here? I added 2 pi. 4 pi over 2 plus pi over 2 is 5 pi over 2. 4 pi over 2 plus 3 pi over 2 is 7 pi over 2. Just added 2 pi to get the other one. If I needed another one, I add another 4 pi over 2, which is 9 pi over 2. And this one here would be 11 pi over 2. But the thing is, when I divide by 2, that's 9 pi over 4. Is that between 0 and 2 pi? No, it's past 2 pi, so I knew that answer didn't work. So I can always add 2 pi to that. Okay? Everybody has this glaze over their eyes. Well, most everybody, not everybody, but. Questions on that? All right, now we've done this a number of times. All right, this technique right here. All right, so it should be a technique that is in your toolbox now that you can use anytime that you have something like this. All right, you're going to change 1 to 2x minus, and you're going to change 1 to 2x plus, and then you have some common things that will cancel out. All right, another question.
Wait, 33 was the easy one.
Yeah, 33 was what we did like kind of yesterday.
All you do is
That's what they did. 150 over 2. 150 cosine.
All right, cosine 75 degrees. We're going to use a half angle identity. So 75 degrees is a half angle of what?
150 over 2.
So that's cosine of 150 over 2. Well, a half angle identity for cosine is plus or minus the square root of 1 minus 1 plus cosine 150
Yeah. Right, that's it.
over 2. Well, 150, the reference angle is what? What's the reference angle for 150?
30.
30 degrees. So what is the cosine of 30 degrees?
pi over 6.
Negative.
Oh, so
pi
neg-
over square root of 3 over 2.
What quadrant am I in 150?
the second
Second quadrant. Cosine in the second quadrant is
positive. Negative.
negative. 75, is that first quadrant or second quadrant?
That is second.
75?
No, it's first.
First quadrant. So should I use the plus or the minus?
Or positive.
Plus, because cosine in the first quadrant is positive. So now all I have to do is simplify. Common denominator. 2 minus square root of 3 over 2 over 2. When I multiply or I have a complex fraction, I simplify by multiplying by what? Reciprocal. Reciprocal of 2 is
1 half.
1/2. So now I get the square root of 2 minus square root of 3 over 4. Which one can I take the square root of?
4.
4. So now I get the square root of 2 minus square root of 3 over 2.
Why couldn't you just use the cosine rule?
You could, but they ask you to use the half angle.
How can we know that, how can I know like 150 reference angle is 30?
Alright, how do we find reference angles with degrees?
So it's divisible by 30, so
Remember, reference angle is always to the x-axis. So if this is 150, how much is this? 30. Always adding to, always subtracting from 180 or subtracting 180 from. Get your reference angle. Any other questions?
35,
Which one?
35.
7 pi over 12.
We had to do 35.
Just asking.
Alright, 7 pi over 12 is the half angle of what?
Is tangent?
24 pi over 12. 6, 9.
Is tangent 7 pi over 12?
Not use a tangent. It's cosine.
No, but 35 is
Oh,
tangent.
oh, it is tangent. I'm sorry. My bad. Okay, tangent. Alright, everybody see 7 pi over 12, the half angle of 7 pi over 6?
Is the half angle or double angle?
Half angle.
I can see why it's a half angle, because it's half 12 on top.
Basically, yes. So where's tangent? Plus or minus square root 1 minus cosine theta over 1 plus cosine theta. If that's the one you want to use. You can, or you can use one of the other ones. So here, plus or minus square root 1 minus cosine 7 pi over 6, 1 plus cosine 7 pi over 6. What's my reference angle? Pi over 6. And what cosine of 7 pi over 6 is? Cosine of pi over 6? Square root of 3 over 3? Alright, what quadrant am I in? Third quadrant. Cosine in the third quadrant is? Negative. That's 1. Square root of 3 over 3.
Wait, cosine pi over 6 is square root of 3 over 2.
What's that?
Alright, I was right.
You were right. I was thinking tangent because it was tangent. I get my cosine and tangents all messed up. Correct. So square root of 3 over 2. Cosine is negative. And 7 pi over 6 is in what quadrant?
First.
Yeah.
7 pi over 6?
No, third.
Negative again, right?
Yeah.
Get a common denominator?
Wait, why is it the third?
Because you go, 6 is 1, is half a square plus 1. This is the third.
So we get 1 plus square root. Let's do this. Trying to hurry on this now. Alright, and would this be plus or minus? 7 pi over 12, is that the first, second, third, or fourth quadrant? Wait, what? 7 pi over 12.
Third, still, isn't it?
No, it's the second.
Second, tangent in the second quadrant is?
Negative.
I use the minus. Alright, your homework's on the board. I'll take the homework that you have, please.